Let's solve the following linear inequality. So when it comes to approaching linear inequalities here, we treat them as if they're equations. One of the only differences in solving an inequality in opposition to an equation is the one rule that says when you multiply or divide by a negative number, you must flip the inequality symbol. So if that happens, if you're multiplying by a negative, dividing by a negative, you need to flip the symbol, otherwise solve as normal. So we're solving for x here, so the first thing I'm going to do is subtract that 5 on the other side. Dropping down the 3x, dropping down our symbol, 23 minus 5 is an 18. Divide out the coefficient here, so we're going to divide both sides by 3, and we get that x is less than a 6. Now when it comes to solving inequalities, most of the time we need to graph them, we need to put our answer in interval notation. So the next thing we're going to do is graph that x less than 6. So we're talking about graphing it on a number line here. So I'm going to draw my number line. We're going to focus on the number 6 since that's what our solution stipulates. And this is that x is less than 6. So we want numbers that are smaller than 6. We want it to the left of 6. So there's two main things when it comes to doing your graph here for inequalities. Take a look at your symbol. That's going to tell you what kind of dot to put on your line graph here. Also take a look at the symbol to know what direction you're shading. If you have a less than or greater than symbol, you're going to have an open dot on your graph. If you have a less than or equal to, greater than or equal to symbol, you're going to have a solid dot on your graph. Ours is a less than symbol, so that means an open dot on 6. Also, our arrow is pointing to the left. Right, we want less than 6, smaller than 6. So that is to the left of 6. So we are going to shade to the left of 6. This is what our line graph looks like. Interval notation, I always like to use my graph and base interval notation on that. Interval notation just gives us the range of our solutions. Our solutions are everything that's less than 6. All right, so 5, 4, 3, 2, 1, all the way down to negative infinity. So when I look at the graph, if it's pointing off in the left direction, that is a negative infinity. If it were pointing off in the right direction, that would be a positive infinity. So on the left side here, because it points off, that is a negative infinity on the left. Our graph stops shading right here at the 6. Right, so our solutions go from negative infinity to the 6. The next thing that you need to focus on with your interval notation is, are you using parentheses or brackets? So going back over here, if you have the less than or greater than symbol, you will be using parentheses for your interval notation. If you have the equal than symbol attached to it, you will be using brackets for your interval notation. Infinities always have parentheses. The implication is parentheses, you're going towards that number, but you don't want it to equal that number. You can never equal infinity, right? So you can never get to it, which is why we use parentheses. So over here, negative infinity, I'm going to put my parenthesis. Over here, 6, we have an open dot. Open dot is also a parenthesis. You're only going to put a bracket if that's a solid filled-in dot. Otherwise, x is less than 6. Our line graph and our interval notation are all part of our solution for this problem.